All right, so we got pictographs coming up now. The cool thing about a pictograph is that it's a symbolic representation of data, meaning you get to choose whatever you want as a symbol for that. Normally we choose like something like clip arty style, like it's very simple and obvious what we're choosing, but you could be fun with it. The following pictograph displays the number of participants aged 15 years or older in the 5 most popular sport activities in Canada. So looking at this pictograph, we want to know how many people aged 15 or older played hockey. So we got to find hockey in our categories, and then we'll find our number of participants over here. So ice hockey, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of these little images. I look down at my legend here. It says one of those represents 10,000 people. So I'm just going to multiply that by 10,000. Or sorry, by 100,000. That's going to give me 1.5 million people play hockey. So the thing we have to be careful of there is making sure we're reading that legend and we don't accidentally say that there's 15 people in Canada playing hockey. Next example that we're looking at here, how many Red Delicious apples are in the store? So I look over here, start to understand it's apple varieties found in a store. Here's my categories, and over here are my actual frequencies. I see that a whole apple represents 10 apples, and a half apple, half of a whole, obviously represents 5. So I'm going to find my Red Delicious apples. I have 10, 20, 30. I might think of that as 3 of the images multiplied by 10 to give me 30. I can say, therefore, there are 30 Red Delicious apples. One of the problems comes to light here. What happens if we want to represent 11 apples at the store? So that's a little bit difficult based on the legend. So based on the legend, or we could think of that as the images chosen, however you want to describe it, it's difficult. But we could try and give it a go. Like I got a red apple here. We know that's 10. And then I could look and see, you cut the apple in half to get 5. What if I just take 1/5 of that, a little part over here, like this tiny little sliver of a slice? Maybe that represents 11 apples. It's not very clear what I'm doing, and it gets more and more confusing. Which leads us to the idea of problems with pictographs. Pictographs can make a graph interesting, a little bit more engaging. I think we've all seen those on social media where it has a, can you figure out what this number means? And they use scales and legends similar to this one. So in general, we can say some problems with them are that our legends are sometimes confusing because you're dealing with an arbitrary shape. The graphs can be distorted, as in the image that we choose to represent the data by, it doesn't accurately describe that. Like, what happens if I wanted to show an extra 100 people here? How on earth would I show that proportion of that person? Like, that's crazy. Relative frequencies brings up our last idea that we want to talk. Relative frequencies are sometimes hard to determine. So up until now, we've been talking about relative frequencies and how they're actually helpful and we want to use them to visualize stuff. Looking at this pictographs, it's actually pretty challenging to go back and find what the relative frequency would be.